So, well, normally I don't do Star Wars. I work as a researcher. And I work with cancer data. I am a machine learning person and data science person. And we are working at Cambridge University in the UK in basically helping biologists analyze their data. Because they have so much data, they need to use machine learning methods. So I deal a lot with genomic data, with DNA, things like that. And sometimes these things get quite complicated. Like, this is a diagram of a metabolic network from a cell, and yeah, you probably can't understand this. I can't understand this either. I am not a biologist. So what I like to do in my free time is to play with some more interesting data. Oh. I don't think they will use this title for episode 8. But if they do, remember, you saw it here first. So let's talk about Star Wars. Well, I decided to analyze some Star Wars data, and if you think about Star Wars, you think the movies, but they are kind of hard to analyze. So I went online and started searching for other data sources that are available for Star Wars, and obviously there are the movie scripts. And there are some very helpful websites like the Internet Movie Script Database and the Daily Script that publish quite a lot of scripts of movies and very quickly after they are released. I'm not sure that's entirely legal, but for example, the script for The Force Awakens was there in January, so that was very quick. And this is already some type of data that I can analyze quite easily, because movie scripts are extremely formalized. They usually start, they are separated into scenes, and each scene starts with int or ext, meaning interior and exterior. Then there is a name of the scene, there is some description, and then there are the people speaking. And this is easy to parse, right? If I look at and what I can do afterwards is I can just look at who speaks to whom in a scene and create a social network out of this. And that's already some type of data that I can work with. And I looked online, and the scripts were there in nice pre-formatted HTML. So there is this pre-formatted block, and there's in bold, like int, ext, scene name, etc. And every name was there in bold, in capitals. That's nice. That's very easy to parse, at least in F#. Well, when I started doing this, I ended up with a bunch of very, very, very ugly regular expressions. I don't know if that's just me, but I find regular expressions right only. So after I went back to it about a week later, I had no idea what I was doing. So I said, well, maybe I should use some more proper F# methods to do it. I'm an F# person, as you can guess, probably. And wouldn't it be nice if I could just basically split each scene into items, like rows, things like that, and then do pattern matching, match each item in a scene, and if it's a scene title, then do something, if it's a name, then do something else, and if it's just another word, just skip it, and things like that. And that would allow me to separate scene titles and names, and that's everything I wanted. And the great thing in F# is that you can do it. Who has heard about active patterns? Oh, quite a lot of people, actually. Active patterns allow you to pattern match against anything. And that's amazing. I'm not sure this is coming to C# at any point, but it's there in F# for you to use. So I basically just defined something like this. This is called the active pattern. These operators are called the banana clip operators. And this allowed me to just put in all my ugly regexes inside this function. And then I can literally just do pattern matching against anything. And now this is much more readable. You can see exactly what's happening there, like match each item with a scene title or a name, etc. So active patterns are amazing. Look them up. They really allow you to just hide all the complexity somewhere else and then just use it and expose it through the active pattern. And pattern matching is awesome. So I decided, well, let's just run it on all the scripts that were online for all the Star Wars movies. It's a trap. It never works like this. So the first thing, some of them were formatted differently. So this is another format. This is episode 3. It's the prequels. They are strange. The scripts are formatted in a strange way as well. And I created another parser for this as well, parsed it. Everything looked all right. And then I was starting getting like really strange character names. So if you look at this, the second letter, it's not an I. It's lowercase l. What? Why? Why would you do this? They probably just ran it through some OCR system that recognized I as an L. And this completely messed up my pattern matching because suddenly some names are not in uppercases and things like that. So I was a bit lost, like, come on, so what are the characters that actually appear in the films? And if you're wondering who's this guy, it's this scary guy. And then I looked at my data and realized some of the characters are missing, like R2-D2. So I went back into the script, and turns out, if you look at it, the scripts only say things like R2 frantically beeps something. That's not very helpful. And R2 was not the only one. Like obviously BB-8 in The Force Awakens, and Chewbacca. Like what you get in the script, it's usually Chewbacca barks a command, and Han replies, "Boy, you said it, Chewie." No, you didn't. So actually, I think Peter Mayhew, the guy who played Chewbacca, did a great job, because from something like this to like, give so much like, personality to Chewie was amazing. But like, when I tried to extract the characters that appeared there, I can't do Star Wars Social Network without R2 and Chewbacca. So in the end, I decided to basically just estimate how many times would a character appear in a scene if they appeared. And I am a math person, so I went into proper formulas. This is basically just estimating, like a linear scaling, like how many times each character appears in a scene versus how many times each character basically speaks in a scene, and trying to relate that. And on average, every character is mentioned twice as much as they speak, which is very helpful. So this allowed me to basically just impute some of the characters that don't speak. And of course, it's never that easy. Some characters didn't make it into my social network. So for all the fans of Ewoks, I'm sorry. And then some other characters completely messed up my analysis, because I've seen that almost all of you have seen The Force Awakens, and some characters appear there, but they don't say a word. So there was a lot of manual preparation going on as well, and it was a lot of work. But that's the thing, if you are dealing with data, usually you spend most time pre-processing the data. So in the end, I was like, so come on, like, who actually appears in Star Wars? Well, there are ways to get that. And I propose a theorem that there is an API for everything. I'm happy to take any objections later, but there is an API for Star Wars. You can go to swappy.co, and it's an API for everything Star Wars. You can get information on people, starships, planets, vehicles, anything. And it's quite well documented and everything. And when I was browsing the website, I saw that actually they have quite a lot of wrappers around the API. So there was Python, JavaScript, Android, Java. I'm not sure what Android means. It's not a programming language. There was R, there was C#. So I thought, well, maybe I could use one of these, right? Maybe I could. Well, no, I'm doing things in F#, let's do it properly. And then I looked at one of the wrappers, and you can see that the code is not actually very creative, let's say. So let's have a look how something like this looks in F#. And I have a demo for that. And if you go to like the Swappy website, you get quite a lot of like example requests with example responses. And it returns data in a JSON format. So I will use something called type providers. And type providers allow you to get typed access to a lot of different data sources. I'll be using something called JSON type provider, which gives me access to JSON documents. You can use HTML type provider, CSV type provider, XML type provider, SQL type provider, anything. And most of them are in the F#.data library, which is cool. So you saw all that code that I had in the animation, and it was quite a lot of lines. So let's see how we can reproduce exactly the same thing in 2 lines. So the first thing I will do is I will create a type. And I'm interested in people, so I will call it a person. And it will be a JSON provider. And I will just give it the example request. And now I will create a function that will call this and get me information about any person I want. So let's get person. And from the Swappy website, you get information based on ID. So I will have an ID as a parameter. And I will just load the person provider and give it the URL. And that's it. This implements everything that was there before in the animation. So what I can do now is to let p equals get person. Let's take the first one. And now if I do p dot, I get all the information that was in the JSON document that I got back from the service. And you can see that I have information on vehicles, starships, species. It's an information about a person, so it tells me a name, their weight, their home world, their height, hair color, etc. And now you might be thinking, like, wait a minute, what happened here? Because I didn't actually run anything yet. But I have now access to everything that will be in the JSON document when I actually run the code. And it's not just that I know all the items in the JSON, I know their types as well. And that's the magic of type providers. So let's actually run it and see what we get. And now you might be wondering, like, this is not VS Code. Everyone was using VS Code yesterday. This is actually Emacs. This is F# running in Emacs. Yeah. Thank you. And you can see that you get a very nice experience there. You do p dot, and you get all the autocomplete, IntelliSense, everything. So let's get the first person, actually. And it returned a JSON document. And what type providers do behind the scenes, they look at the example request that I gave it before in the URL, and they look at all the items they get back and try to infer the types. And this is really cool. And what I can do now is, I actually put together a complete wrapper around the entire Swappy database. So it's about, altogether, it's 67 lines. And it also does paging, because if you want to download all the information, you have to do paging in the JSON. So 67 lines, that's pretty cool. And this now allows me to do quite a lot of very, very important things. I'll make this a bit smaller. I can download all the people. Oh, I didn't load this. Now I loaded my script. Now I will download information about all the characters in Star Wars. Hopefully the internet works. Should be running now behind the scenes. Did I run it? Yeah, now I have all the information. And I can find out, like, for example, what's the most common eye color in Star Wars characters, because that's obviously something that we all need to know. So I ran that. So actually, the most common eye color is brown. For example, Yoda has brown eyes. Well, that's something I needed to know. The second most common is blue. And the third most common eye color is yellow. Well, who would have guessed? Darth Vader has yellow eyes. Good to know. And I can also verify some things. If you remember in the original Star Wars movie, Luke Skywalker is trying to save Leia, and he walks into her prison cell, and she says, dressed as a stormtrooper, and she says, "Aren't you a bit short for a stormtrooper?" Now we can verify that. So Luke's height is actually, this is in centimeters. I'm not sure how much it's in feet, and inches, and things like that, but it's 172 centimeters. And I can check it against the average height of all Star Wars characters, and that's 174 centimeters. So yes, she was right, he is on average shorter. Great to know, right? So what I did after this, I sent a pull request, and now you have the F# wrapper as well. But you really shouldn't clap, because it was 67 lines of code. So I encourage you to go play with this. It's on my GitHub if you want to play with the F# wrapper as well. So this is a lot of fun. And now I could actually verify if the characters actually appear in the scenes, etc., and what are their actual names. So I had a list of scenes, I had a list of characters. So that's basically my social network, because now I can just extract which character speaks to whom in which scene. And the first thing, if you are dealing with data, you need to visualize things. And how else to visualize things if you want them to put them on your blog afterwards? Well, you use JavaScript. So there is this JavaScript library called D3. And I don't know if anyone of you has ever used it. It's extremely flexible. So it can do almost anything, any visualization. But as I said, I'm doing things in F#. So I use this very cool new project called Fable, and that's F# to JavaScript compiler. And if you go on the website, they have quite a lot of different examples and samples. You can see how to write Pac-Man in F# and compile it into JavaScript and play it in your browser, which is cool. Well, this is me losing in Pac-Man yesterday. There are some samples with Node.js as well. But I wanted to show you the actual network. I promised you JavaScript, so this is just an image. I'll click on it, and it will take me to my JavaScript animation. So this is the social network of Star Wars. And because I was talking about Fable, let's look at the page source. Oh, sorry. I wanted to inspect. And because I wrote everything in F#, and after that compiled it into JavaScript, I can actually go to the source right here. And this is my F# script that I compiled into JavaScript. And because Fable produces something called source maps that basically map the JavaScript to the F# code, I can now debug anything in my F# code in the browser. So I can set breakpoints like here, and then I can run it. And it will stop on the breakpoint in my F# code. So it stopped in a stage before it actually created the visualization. So now all the nodes are here in the top corner. And this is pretty cool. So look at Fable. It's a very cool project. But let's go back to Star Wars. You see that the network is quite big and complex. And the thing is, if I hover my mouse over anything, it will show me which character it is. And I can play with it because it's JavaScript. And the black big node is Darth Vader. And this already shows us how some of the films look. Because on the sort of left side, the left side, are the prequels that have very complex network with a lot of little nodes. Then in the center here are the original episodes. So you can see that there are just a couple of very big nodes that are strongly connected. And here on the right side is episode 7. So all the nodes there are usually very small because they don't appear that much yet. So we'll see how that looks afterward. And I'll go back to my slides. I'm running my slides. I was debugging them earlier because they are running in JavaScript as well, and I wrote them in F#. But I'm using something called FS Reveal. OK, so let's look at some of the episodes in detail. So this is first episode of the prequels, and you can see it's quite complex. You probably can't even remember most of the characters there. Yeah, there is Jar Jar in the center. And if I compare it to the original Star Wars, wow, the network looks completely different. It has just a couple of big nodes that are connected. And yeah, almost all of them have names here because I just highlighted the main characters. So you can already see some differences and what maybe went wrong with the prequels. And this is The Force Awakens, and the network is a bit bigger, but it doesn't have such a very dense connections that the first episode of the prequels had. So that's probably a good thing. Well, I am a data scientist and a machine learning person, so I decided, well, let's quantify the differences. Because you can see some patterns, but how does it actually look quantitatively? So the first thing I can look at is to just look at the size of the network, number of characters. And this is showing the number of characters that spoke in at least 2 scenes and that had specific name. So there are no characters that are just Stormtrooper or Pilot. And yeah, episode 1 has the largest network. It had 38 named characters. That's a lot. And then episode 4, the original Star Wars, had just 22 characters. And now episode 7 jumped up to 27. So let's hope they won't overdo it too much. And we can look at some more sophisticated measures of complexity of the networks. So one of them is density. This is my example social network. And density basically just compares how many links are in a network compared to how many there can be potentially. So this is just looking at dividing the number of links that exist in the network with the number of links that are there potentially and maximum. And this is how it looks for all the networks. And I think you can guess that episode 1 was one of the worst. It has the lowest density. That means it has a lot of nodes that are not that connected. And episode 7 is actually very similar to all the other episodes, which is good. That tells us something that the characters actually communicate with each other, which is nice. I think episode 6 here is a bit of an outlier because I didn't include the AVOCs. Sorry. And I can look at other bit more complex measures as well. One of them is clustering coefficient, where if I look at this guy, and then I look at all its connections, I can compare, do his friends know each other or not? And if they know each other, that means, in terms of the story, that the characters communicate within groups. So in this case, there are 3 neighbors, and 2 of them know each other. And if I look at this guy, he has 3 neighbors, and all of them know each other. So in terms of story, if a network has low clustering coefficient, that means it just follows one person that doesn't interact, and the people the person meets don't interact with each other. But if a network has large clustering coefficient, that means everyone interacts with everyone. And I think you can already guess how that looks as well. And episode 1 is the worst. So it has a lot of characters, the network is sparse, and it has small clustering coefficients. So all the debates in the Galactic Senate were not very useful for the story, actually. And again, episode 7 is actually doing quite well, so I think this is something they did well, and hopefully they will continue with this. And I can look at other measures as well, and now I am interested in seeing who is actually most important in the story. So one thing I can do is to just look at the degree, which is just the number of neighbors each person has in the network. So for example, this guy has 6 neighbors, which makes him very central in this network, compared to this guy who has only 3 neighbors, so he's a bit more on the edge of the network. And in terms of the story, this is just how many scenes each character appears in. And there are other measures as well. Well, this is how you would write it formally. And there are other measures as well, and because if you just look at how many scenes each character appears in, that doesn't actually tell you how important the character is to the story. Because if someone just tags along and appears everywhere, that doesn't tell you if that person is important. So there are other measures, and one of them is called BitVenus, and that tells you how much a character connects different communities. So for example, this guy, the way it's computed is that I look at how crucial this guy is for communication between other nodes in the network. So if I look at these two, the green guy is very important for that, because these two don't know each other, so they have to go through the green guy every time they want to talk. And if I look at these two guys, they have alternative ways of communicating as well, so the green guy is less important for communication. And the way you would compute it mathematically is that for each node, you look at all pairs of nodes, you compute the shortest paths between all the nodes, and count how many of them go through the node that you are interested in, and then take the average. And now you're like, oh, that's kind of a lot of work, right? Like, that's not one-liner, because you have to actually do like a pathfinding algorithm in a network, so that's a bit more work. And I am a lazy person, so if you are using R, there is a library called igraph, and you just call a function called BitVenus. Well, luckily in F#, I was mentioning the JSON type provider, but there is something called the R provider. So luckily what I can do in F# is just open the igraph library from R and call it from F#, and it's just R dot. That's the same thing with I had before with the JSON. I get if I do R dot, I get all functions I have in my R installation, and I can do R dot BitVenus. This is amazing. So now you must be thinking, so what are the results? And for example, for episode 7, if I look at just the degree, that means like the number of connections in the network, the most important person is Poe Dameron, which is the resistance pilot. The second is Finn, etc. And for BB-8, that's an approximate number, because that's approximated. BB-8 doesn't actually speak. But if I look at BitVenus, because now you might be thinking, well, some of the main characters are missing. Well, if I look at BitVenus, it looks very different. So Poe is still very central, because he connects quite a lot of communities, because almost no one of the other characters actually speak to any other resistance pilots. But suddenly the second one is Kylo Ren. He connects communities quite a lot, so he's important to the story, and Rey, etc. So you can see that the order changes quite a lot. And now the key question, who is the most important in the galaxy? Well, before episode 7, well, this is Poe just celebrating. Before episode 7, it was Obi-Wan Kenobi. And when I reran the analysis after episode 7, well, Darth Vader still rules the galaxy. So, you can use the same things in the real world. For example, I ran some network analysis on Twitter data about the F# community. I looked at the Twitter account of the F# Software Foundation, F#org, and I looked at all the nodes that are connected to it on Twitter. And then the most central person there is actually Don Syme, who is the creator of F#. So this is great. If you just download some data and run analysis, and it tells you something that corresponds to what you actually know or what your intuition tells you, this is great. Because now you can go and, like, if you don't know who's the most important in the C# world, you can do exactly the same thing. And this will tell you. I haven't done it. If anyone wants to do it, all the code is on my GitHub, so you are welcome to play with that. And what I was doing later, I was reading some paper, like an academic paper on cancer and genes, etc. And I came across some analysis where they looked at betweenness of genes that are important in cancer, like tumor suppressors and oncogenes. And they actually found that these genes have higher betweenness in biological interaction networks. And that's great, because I was like, yes, I know what betweenness means, because I did it for Star Wars. So what I want to say is that this might look like a toy example. Oh, nothing against Star Wars. I think Star Wars are amazing. But sometimes it's good to use these toy examples to get intuition about more complicated computational methods. And if you want to go into data science or machine learning, this is a great way to learn, because this gives you very interpretable data set, and if you get some results out of that, you understand what they mean. So if you just look at genes, I have no idea what all the names mean. But if I know how the algorithms behave in the Star Wars setting, suddenly I can translate that knowledge. So play with data. So I think I went through quite a lot of things. I showed you how to parse scripts with active patterns. I was talking about calling everything from F#, which is very polyglot. I was showing type providers. I was showing you how to get from F# to JavaScript with Fable. I was talking about quite a lot of things from the network science. But the main thing is just have fun with interesting data. So play with data. If you like Star Wars, I have everything on my GitHub. You can play with that. If you like Star Trek, well, you can parse the scripts as well and do the same analysis. And just find something that you find engaging and fun and play with that. And I have quite a lot of links here. You can look at them later. I have also a Neo4j demo that you can play with the network. Yes. Everything is on my GitHub, and if you want the links, I don't want to go through them. They are on my talk website. Just go to evelinag.com/StarWarsTalk. Thank you.